There may be only 3 months to the end of its mission, but Rosetta is still busy studying comet 67P Churyumov-Gerasimenko. And recently it broke a new record by flying an orbit 7 kilometres from the comet's centre. That's just 5 kilometres from the surface, with more breathtaking manoeuvres to come.
On the last few months of its life, we'll try and get even closer. So, we won't be able to be in orbit around the comet, so we'll go on elliptical orbits, but with a very, very low pericenter. The pericenter is the closest distance to the comet, and we hope to be able to reach maybe a kilometre to the surface, maybe a bit more, maybe a bit less, we'll see.
The spacecraft has been orbiting the comet for almost 2 years, following the comet as it approached, encountered, and moved away from the Sun. We know that although it looks rocky, the comet is so light and porous that it would float on water and surface temperatures go down to -100 degrees C, and that gases streaming from the comet include hydrogen sulfide and methane.
We've seen tremendous changes in the amount of gas coming off, factors of 1,000 between when we first got to the comet to when the comet was closest to the Sun.
Asteroids and comets could have brought water and organic molecules to Earth at a crucial stage of its formation. By collecting and sampling the comet's gas and dust, we know that its water is not the same as that on Earth. However, Rosetta discovered ingredients that are considered important for the origin of life. This includes finding phosphorus on a comet for the first time, and also glycine.
It just shows that the comet contains very complex organic molecules, including amino acids, which are essential for life. And we also see that this glycine was formed before the solar system was formed. And that makes glycine amino acid something like universal. If you have it in comets, you will have it everywhere in the universe. So that then lets you dream about life elsewhere.
Repeated measurements of glycine were confirmed in the comet's atmosphere or coma. The only amino acid known to be able to form without water, it is thought to be released by icy dust grains after they have warmed up in the coma. Argon was also detected in the coma last year. More recently, the ROSINA instrument has now detected 2 more noble gases during the period when Rosetta was flying close to the comet.
We have now Krypton and Xenon, and we have most of their isotopes, which is absolutely essential to understand the history of the solar system formation.
Detailed analysis of these detections and how they relate to the origin of comet 67P, as well as the wider question concerning the role of comets in the evolution of our solar system, is now underway.
This has been a unique opportunity for our scientists to acquire invaluable data. This will remain a masterpiece of spaceflight, the mission itself, and the data we have been acquiring the past weeks will allow our scientists to further exploit the scientific results of Rosetta.
Yet more science will be released over the next few months and for many years after the orbiter spirals down to the comet's surface at the end of September. The incredible story of a comet is not over yet.